Okay, you might not be able to see this very well, but it is on Canvas for you. It says writing equations to model and solve real-world problems. Here's example 5. A rectangle is twice as long as it is wide. Its perimeter is 48 centimeters. Find its dimensions. Okay, for this, on Canvas, I said you are going to want to draw a picture of what we know. Okay, we know it's a rectangle. There's our rectangle. And we know that it's twice as long as it is wide. It's not technically drawn to scale, but it's close enough. We'll say this is the width here, and then here is the length. Okay, in perimeter, we have to know what perimeter means. It's the distance around. We already wrote that definition down, at least we should have. Perimeter's distance around an object. So basically we would add all 4 sides up to find the perimeter. So we don't know width, we don't know length, but we know that the length is twice as long as the width. So for these problems we can say, all right, I don't know my width. So what do we use when we don't know something? Variables. My width is x, and I know my length is twice as long as my width. So what's 2 times? Twice? 2 times an unknown is just 2 times x, 2x. And we can use our rules or the laws or whatever you want to call it of rectangles. And I know that if this width, if this side is x, this side has to be x because they're parallel sides. And they equal the same length because it's a rectangle. Same here, if this is 2x, this is 2x. And now I can use the definition of perimeter and add all 4 sides up. 2, 3, 4, 5, 6. So I have 6x equals the entire perimeter, which is 48, and solve for x. 48 divided by 6 is 8. You're not done. X doesn't equal 8. That's not the answer. It's not the final answer. It asks, go back to the question, find its dimensions. What's the length by the width, or width by the length? So we take x and plug it in, or take 8, plug it in for our x, just like evaluating expressions now. Take the value, plug it in. So our width is 8 by our length, which is 16. Some of you might have said, well, I can figure that out in my head. Fine. That's great, but for practice, because we're going to get more difficult problems, I want you to try to write the actual equation to figure it out, or write the equation to figure this one out. All right, let's go ahead and look at example 6 then as well. Example 6 here says the sides of a triangle are in the ratio 12, 13, 15. The perimeter, once again, is 120 centimeters. Find the lengths of the sides of the triangle. Draw triangle. Okay, I have no clue what side is which, so I'm just going to start labeling. Say 12, 13, 15. Now those aren't the actual sides, but I know that's the ratio of the sides. And I know for a fact it's not the side lengths because if I add that up, it does not add up to 120. So, but I know that this side has to be 12 times whatever. This side has to be 13 times whatever, and this one has to be 15 times whatever. So I'm going to actually label this as 12x, 13x, 15x. Now, again, using our definition of perimeter, add all the sides. 12x plus 13x is 25x plus 15x is 40x equals 120. Divide by 40. X equals 3. Boom, done, right? No. It says find the lengths of the sides of the triangle. Since x equals 3, my length of this side is 36 because we do 12 times 3. Don't forget to label 36 centimeters. 13x, 13 times 3 is 39 centimeters, and 15 times 3 is 45 centimeters. Now you're done because we found the lengths of the sides of the triangle. Let's go ahead and look at example 7. This is a fun one. So the space probe leaves Earth at the rate of 3 kilometers per second. After 100 days, a radio signal is sent to the probe. Radio signals travel at the speed of light about 3 times 10 to the 5th kilometers per second. About how long does the signal take to reach the probe? What makes this fun here is the fact that they are talking about that it travels 33 kilometers per second, but it's been going 100 days. So there's a lot of conversions we have to do there to actually make this work. So we have to convert this 3 kilometers per second to figure out how long it takes each day. So I'm going to go from day to minute, from second to minute. There are 60 seconds in 1 minute. So 3 times 60 is 180. So now I'm at 180 kilometers per minute. Okay, but we're not even close to days yet. So now I have to convert from minute to hour. So again, how many minutes are in an hour? 60. So 180 times 60 is 10,800. Okay, great. Now I'm at kilometers per hour. Still doesn't do me any good. Still need to get to days. Well, how many hours are in a day? 24. So I have to do 10,800 by 24. And I get 259,200. And again, that's kilometers per day. Okay, so I figured out kilometers per day. But now, they've traveled 100 days. So now I have to take this per day and multiply it by 100. And we're going to get 25,920,000. So, great, we're done, right? No. That's just how many kilometers after 100 days. Okay? So now I have to figure out how long it takes the signal to reach the probe. Radio signals travels at the speed of light about 3 times 10 to the 5th. So that is 300,000. 3 and then those 5 zeros. So to figure out how long it's going to take this to overcome that, divide. So we have to take 25,920,000 divided by 300,000, and we get 86.4. How long? Seconds. Or, if we wanted to convert it, we could say it's actually 1 minute and 26.4 seconds. If you have any questions, make sure you bring it in tomorrow. Have a nice night.